Thank you for invitation. A year ago, we had this initiative starting, and I remember we had very interesting discussion with the ADA students. So this year, unfortunately, we cannot meet face to face, but the technology gives us a chance to actually have some kind of virtual meeting. So thank you for this opportunity, Ülviye Hanım, Saleh Malim. So my name is Araz Yusupov. I'm the Dean of School of IT and Engineering at ADA University. And I was asked generally to talk about our school. And as far as I remember, the point was about, if I'm not wrong, about career-related kind of thing, or career selection-related information session, if I'm not wrong. If we look from the perspective of career, the School of IT and Engineering right now, we are offering 3 bachelor degrees, 3 bachelor degree programs, Bachelor of Science in Computer Science, Information Technology, and Computer Engineering. And if we look at it from the career perspective, I think that globally, these are the directions which are very popular. There is a need for high quality specialists in the area. And starting from this year, by the way, we have started also our first master's degree, Master of Science in Computer Science and Data Analytics, which is an interesting program, a dual degree, dual diploma program, jointly with the George Washington University in United States. So that's short about the programs we have. Speaking of career again, usually we would tell interesting fact about the skills, global skills demand. There is a nice report by LinkedIn. Probably everybody knows what LinkedIn is. It's like a Facebook for your career, or kind of a professional social media, where people would put their profiles, look for jobs, and then companies would have also their profiles. So they have the report about global trends of the skills or professions needed. And for the last, I think, 3-4 years in a row, top 10 skills on demand are all related to information technology or somehow computer science. So that's a good indication or illustration for the global demand for that. And then there is also local demand, obviously, that while many organizations are talking about digitization, applying innovations in their daily businesses, if you look at our majors, all of them actually computer science based. Sometimes we call it in Azerbaijan informatica, meaning informatics. These are all related fields which are rooted in computer science informatics. But then there are some differences, obviously, between the 3 majors. I can explain in short what are they about. So if you look at the computer science, it's a classical program, and then mainly it is focusing on, let's say, algorithmic side. Like all our students, basically, they start with the same kind of foundations, and it all comes to algorithmic thinking. So if we summarize this, the foundation of this majors, but I want our students also look at it from the perspective of general kind of philosophy of the field and then where we are. So if we start looking from that perspective, so currently we are going through dramatic change. I mean, you all are experiencing that. Computers are everywhere, and then we call them thinking machines. But then to make this possible, you need some technology and some, let's say, field of science, or which is basically computer science. And then sometimes people say that we are now experiencing fourth industrial revolution. If you remember from the history, the first industrial revolution started with invention of manufacturing machines. Steam engine was there. Then the second stage was that they were conveyors, or like production pipelines. Mass production was around, electricity. And then third industrial revolution came in with automation, and then computers started to actually emerge there as powerful means to change the industry and change the lives. Now, important thing to understand is this first industrial revolution, the main philosophy behind was so-called scientific thinking. And the main premise of the scientific thinking was you can understand everything around. So basically, cosmos is understandable. What does it mean? I mean, we see the results even today. Like in school, you learn physics, chemistry. Probably you wonder, why do you learn all of this? But then generally, you learn this because you need to build up scientific thinking to be able to actually contribute to the modern society, contribute to the technological advance, and then basically you can understand everything. What does it mean? If it is raining outside, you don't say simply, "Oh, it's a miracle." Oh yeah, maybe it's a miracle, but then you can understand that. So that's the main premise. But then scientific thinking emerged as a way to understand everything, which led to lots of inventions, as we know, lots of new technologies coming up. Now, if you look at the other end of, and then now people talk about computational thinking. So computational thinking emerged as the means for controlling the world. That's, in short, you can tell like that. And then basically the main premise of computational thinking, you can compute everything around. Cosmos is computable. Or in other words, you can kind of calculate everything, or you can automate everything. And then, for example, some years ago, people would say, I mean, can you teach machines to recognize people? No, impossible. I mean, a little child of certain age, they easily recognize faces, faces of mom, dad, and others, but the machines will never be able to do that. But now we all know that machines are able to do that. So that is the result of computational thinking. And the central notion there is algorithms. Algorithms as a notion are very old. And by the way, interesting fact is that the name algorithm comes from our part of the world, from the name of medieval scientist from Khwarazm, Muhammad al-Khwarazmi. So it's Latinized name of al-Khwarazmi, algorithm. And basically, this is kind of, if we simplify the definition of algorithm, it's a finite kind of, basically set of steps which would lead you to achieve your goal. And interesting kind of example for algorithms would be, let me show you one interesting thing, by the way. So I've got a nice book here, which is called A Book of Tasty Algorithms, with foreword by Donald Knuth. So Donald Knuth is a professor emeritus in Stanford University. He's very famous in computer science. He's called Yoda of Silicon Valley, if you know who Yoda is. But then he's very important. Some people would call him patriarch of computer science. And then basically it's his photo in the back. Yeah. But then if you look inside of the book, by the way, we published this book as a present to the participants of International Olympiad in Informatics, which was hosted in Baku back in 2019. So if you look inside, I mean, there is a nice intro by Donald Knuth. But then if you look, what are these? don't be surprised. This is in fact the book of Azerbaijani cuisine. So a nice example of algorithm is actually a recipe. Yes. So you have some finite steps. If you follow the steps closely or masterfully enough, you would get tasty results. Yeah. So yeah, obviously algorithms like they're not only about the cuisine or they're not only about recipes, but then you may have recipes for everything, for recognizing the face, for finding the shortest path to your home, for calculating the distances to stars, or finding out what is the state of sales in certain organizations. So different ways of doing that. But then eventually, what is that all about? It's all about like making machines to do certain let's say job in a faster way, in a more accurate way, so possibly, if in short we put it like that. Now, so you can understand that the invention of the thinking machines, we are all now using them, and then in many cases, many fields actually had this tremendous progress thanks to actually application of these computing machines, computers, or now we generalize it like information technologies. At the end of the day, it's all about processing information and getting used information and making some things happen. So basically, all our majors are actually connected to this field. And then if you look at the modern computers, you can immediately differentiate two parts there, which are broadly called like hardware and software. And then hardware is kind of tangible parts of your computer, and then bigger computing systems. You may have network, and other equipment there, which is you can touch it. Yeah, it's basically right now we see like lots of electronic devices which are actually able to help with storing data, processing the data, inputting, outputting the data. But then now software part is very much related to algorithms. Yeah? So basically, it actually, why it is called software, because it is in you cannot touch software generally. Yeah. And then there is when we talk about software, you would usually talk about computer programs which are actually making this hardware work. Yeah. And then if we talk about computer programs, what is that? There is a nice book actually called which gives actually a definition of a program. By the way, it's a classical book by the way, I've got this book here. Yeah. So basic algorithms plus data structures equal programs. So basically, computer programs are actually governed by algorithms. Now, why I talk to you about that, so you would have clearer understanding, and then we would link it to our majors now. Now, if we look at computer science major, this is mainly about algorithms. Then computer science students, they would start with the same foundation. Yeah, you would need to have some mathematical background. So to be able to actually solve the life problem, some problem algorithmically, you would need to build up a mathematical model of something. Yeah, and then you would actually think of the steps which would solve this problem. So you would need to have some mathematical background. You would need also to know principles of programming, and then you would need to build up your algorithmic thinking basically. And then computer scientists later, they focus more on algorithms. They focus more on software. They work on optimization, making the algorithms faster. Making them more efficient, less resource greedy. Yeah. And there are many interesting things. They would learn also specifically software development, software engineering. They would look at the theory of computation. They would also deep dive to the fields like artificial intelligence, machine learning. Basically, that would kind of do. And then where they would find their career leading them, anywhere where there is a need for actually not only coders, rather software architects or software developers. Yeah, so it's also about understanding the problem, bringing the solution, developing and designing solution. So the coding of the solution is usually lost. If we think about computer engineers on another point, on another end, they are mainly, they would also know the programming and all the foundations, but then this field is rather, if we oversimplify, they're more concerned about hardware part of the thing. Yeah, they would deeper understand how the digital logic is designed. Yeah, they would understand deeper how electronics work, so they would learn electronics. They would go deeper to physics. They would understand the chemistry from the perspective of understanding the material used in hardware. They would learn something like signal processing, control engineering, and basically they would have interesting electives like mobile robotics, embedded systems, microprocessors. So that's another field. And then the third one, information technology. So nowadays, you all know that this is not a matter of single, computer with hardware, software. The progress is achieved thanks to applying these technologies on an organizational level, on an industrial level sometimes. So this demands some other kind of skill set to help, for example, organizations to apply all these technologies to resolve their problems or to actually achieve some advantage. Yeah? So IT specialty, information technology students would focus on this field. Yes, they would still have these foundations. They would be able to actually understand the software side and hardware side of computing systems, but they would learn something like system analysis and design. They would have some core courses like IT project management. They would also learn deeper like business process modeling for IT solutions. And then they would also look at the fields like, for example, big data. Yeah? We have nice courses, Introduction to Big Data Analytics. And then as a result, they will be able to actually apply this skill set to develop, design systems which would help, organizational level change. Yeah, I mean, hardworking students. so we, as a school, we are infamous for being the tough school. I mean, general engineering schools are tough. But then, if you look at it, you should be interested in the field, and then you should be interested enough to actually spend, like lots of time learning the field. Obviously, the good help would be though, like for the starting. Basically, starting at university is a bit stressful experience for any specialty. University education is somehow different from school education, and then we usually see the pattern of students joining the university, and they sometimes they struggle in the beginning for different reasons. But then if you start with these majors, you need to have a robust mathematical background, and then I need to actually explain it a little bit. It's not about like you kind of know formulas or something. Like you need to feel, you need to have kind of interest in mathematics. You need to be able to look at the things around and then understand what are the mathematical rules of these things working around. So possibly you would also understand some physics, because physics is the way to understand the world around. Yeah, mathematics is usually an apparatus. And then if you would do some experiments with programming, that would be helpful, because right now this is very accessible, unlike like uh, 20 years ago. Now computers are around. There are lots of tutorials. There are lots of uh, easier ways of programming the machines, and then try putting together some small programs. If a student already experienced that, and then they feel like it's a field they're interested in, they can do that. That would be a good indication that this is their field. What I can tell in addition, that and then usually we start like people would have different motivations to actually enter university or joining university or applying to the university. So there are many different motivations. And then also choosing the major, there might be different motivations why people choose. What is important now, right now, we are seeing the trend. Finally, in our society, the interest is turning towards this field, towards the fields of information and communication technologies, computer science, computer engineering. But then we should be very careful with that, because maybe you are not very much into that. So that would actually, lead to lots of struggles. So basically, in short, you should be interested in the field. You should feel the capability of actually, learning this. And then I believe everybody can learn. By the way, there is a myth that no, like not everybody can, like even simple skills like programming. I mean, everybody can learn programming. That's I believe in that. That's a mere fact for me. But then going deeper, because university education is not only about being able to do something, it's about being able to understand something and eventually being able to contribute to the field or do some high level problem solving in the field. So I guess I gave rather very long answer to this simple question. But that if to sum up everything, so the students we expect would have interest in the field, they would have a passion in the field, I would say, and they would try already some stuff. They would have strong background in math, and they would also have also background in sciences. Math and sciences would be good, and then they would already try some programming around, so that would prepare them for these majors. Certainly our previous graduates or previous students, they were never intimidated as girl students or girls students. They were never intimidated. Furthermore, I would say that in majority of our best graduating students, they were girls. Like I remember our first graduation ceremony, when we had actually a privilege of having head of the state coming to the graduation, and then there were people like the best students, best graduates of ADA University from all the schools, coming to the podium to get their diplomas from the president himself. And you know who was the first person to get it? She was graduate, among the first graduates of School of IT and Engineering. So best graduate of ADA University in this year, 2018, was the graduate of School of IT and Engineering, and she was a lady. So she was a girl, Chonul. I think she was Gurbanlı, but now she's Bağırova, I guess. So now she is continuing her studies in Germany in master's program. But then I agree that this is a known phenomenon of actually having, generally in engineering, there are less girls than boys. But certainly we are trying to do a lot to actually change the picture. There are lots of reasons and there are lots of theories why it is happening. But generally we have quite a lot of number of girls and then they are very successful. And then historically, if you don't know, the first published programmer was Ada Lovelace, the British mathematician, and then Ada was she. So basically, she she was. By the way, interesting fact is that she was a daughter of Lord Byron, the famous poet. Was very capable mathematician. And then imagine her, I think, if I'm not mistaken, her work was published back in 1843, where she put together the first known published algorithm or outline of algorithm for calculating a certain problem using a mechanical computer. So that's very fascinating. But then what is more fascinating is that even back then, Ada was able to actually see the future, because at that time, people would see basically these calculating machines or computers, if we call them, as we call them today, as machines to crunch numbers, yeah, calculate numbers. But she was talking about composing music using these machines and doing all sorts of things we are now seeing today. So she was very forward-looking person, I would say genius. Her genius is in actually understanding this. While the inventor of this mechanical computer himself, which is also a very important person, Babbage, he wouldn't see that yet. Yeah? So that's very important to see that the actually in the beginning of the field, the main profession, central profession, the programming profession, is started by a lady. So why not to have more girls? And by the way, we are actually running a traditional event for 5 years now. This year we had the 5th one, Ada's Legacy event, which is mainly about promoting role of girls and then promoting the field among girls, having more girls in the field. And then another goal of this event was actually also inspire Azerbaijani students to actually participate in the global events. There is a pan-European event which is called Women Courage. And then after we started our local event, more and more Azerbaijani girls and boys, by the way, they started to apply, get scholarships, participate in this event. What's very interesting is that we actually hosted this European event this year in ADA after these long years. Our bid was successful, and then we hosted the first virtual Women Courage event in Baku in Ada University. We had 200 plus registered participants from 5 continents. So since it was virtual, it became global. So what I want to say generally, in fact, software, if you look at the history of the thing, software, like ladies and girls, women were big in software part of this realm. But then once the software started to become very important, and then you can quickly say that because the richest man in the world, which was kind of a cliche maybe, Bill it was actually head of a software company. And then he's the founder of a software company. Basically, once the software became more and more kind of important, it became more competitive. So the men started to compete there too, I guess. More and more boys started to go there. We certainly want to have balance there for a reason which actually I think important generally. Diversity of views is very important for development of any field. And then certainly the example of Ada Lovelace and Babbage, showing that actually this, how two different people would look at the same thing from different perspectives, which actually lead to progress. So in short, I would very much encourage our girls too and boys to come to the field. It's very fascinating field. It's very creative field. So in short, that's all. No matter what specialty you choose, no worries. Like, we actually have very brilliant students in School of Business. They learn economics, they learn business administration. We have brilliant students who learn, I would say even further, like this is also very important field of, public and international affairs. Yeah, this is important. Or, kind of governance is generally important. Sustainable development is important. But no matter what specialty you are choosing or what profession you are choosing, I think there is a benefit of learning the basics of computer science. And then we see this trend too. We have more and more students from the other schools. They are trying to take, or they are taking as their electives, programming courses. They take like algorithms, data structures courses. They take artificial intelligence courses. They take introduction to big data analytics courses, because it's everywhere. And then interesting fact is that among our current master students, we have lots of students which are selected. We had very tough selection process from all over Azerbaijan, from all universities, I would say, top universities in Azerbaijan. Among them, we have also ADA university students, but some of them are actually graduates of business school, for example. Why? Because they were able to take during their university years some courses from our school. They build up their second track in computer science mainly, or IT, and then they had the skill set to actually be admitted to Master of Science in Computer Science or Data Analytics program. Another interesting fact is that, for example, last year we had one of the graduates of SPIA, School of Public International Affairs, and she was, by the way, she was so brilliant. She was taking our programming courses, and she was a straight A student, the A plus student. Even though, like, so basically, she was great so much that our teacher, our professor, actually recommended her to be his teaching assistant for next years. And then she ended up working for IT industry. So you never know. And the ADA is a great place to actually, and then we have a chance of getting electives and then starting it in a more planned manner, have a second track in certain field. So any student who is very much interested in business, I mean, we need specialists in all areas, but they may take 1-2 courses to actually learn about what is that, what is computer science, what is information technology, at least, or some of them are actually having, shift towards this industry. I would also encourage potential SPIA students also do that. You probably saw recently the hearings about Facebook problems, etc. It was very illustrative that some policymakers, it turned out they have no idea how this information technology works, which is very dangerous. If you are a policymaker, if you are a public affairs person, it seems that in modern days you should have somehow at least some basic understanding of what is behind information technology. That's a nice feature. We are hoping that it will be used more and more. So basically, students inside site, they can choose, like for example, you can actually be focused on computer science, but since you are into hardware more, you can actually start off in a planned manner your second track in computer engineering. But also in parallel, anybody from, for example, economics program, or business administration program, or public affairs program, they can actually pick up one of the tracks, one of the majors, and they can do second track in computer science or IT or computer engineering, which fits them. It would be a bit different if you are a site student or you are outside of the site, naturally, because there are differences. But then general rule is, I think second track means you would need to spend your free electives, plus you should be strong enough to take 2 courses overload to fulfill this 6-course small set of core for second track in any field. And the same applies to our site students. They can actually, and this is happening too, some site students, for example, you can major in IT, but then you would be interested in business administration more. Yes, so you can also select your free electives in a way that you would fulfill second track in business administration or economics, or maybe you are into the public policy. Yeah, you would take the courses from School of Public and International Affairs. So we are actually accommodating that. And when it is done in a planned manner, it works, but it is hard, obviously, because you need to be on certain level to be able to take some overloads, some semesters, to fulfill your 6-course track requirement. That's very important question, and then very popular question we are asked. My answer to that question is, pen doesn't make one a poet. Similarly, knowing some language doesn't make somebody a programmer or computer science. So basically, in the beginning, it doesn't really generally matter. There are even ways of learning programming without learning any language. The visual programming tools. We would usually, some of our students, possibly they heard about the global campaign, which is called Hour of Code. And every year it is happening in the International Week of Computer Science Education, which is the week around 10th of December. I think early December is it's birthday of Grace Hopper, by the way, another lady computer scientist. She is a very interesting person. I would recommend everybody to Google her. She's credited with developing the first, I guess, compiler for a high-level language. Interesting fact is that she was actually a Navy admiral, I think Rear Admiral. Very decorated person, and she was a very important person in the beginning of computer science history. So this week, during this week, the campaign is about spending 1 hour learning coding, programming, or teaching programming. And there are lots of puzzle-like tools which are available through the website code.org. code.org. So Code.org is a organization which actually started the campaign, and they have nice website with lots of materials. So I would recommend everybody to test this. So first of all, without even diving into the language thing. Now I want to touch upon this language question because it's somehow a point for many of our students. And this is about focus. So the focus shouldn't be learning languages. And then we have a joke I oftentimes tell our students, that you need to learn writing poems, instead you learn words. Like, you shouldn't focus on learning languages, rather you need to focus on learning how to write a poem in that language. But then at the end of the day, there are certain languages we are actually building around our courses. So Programming Principle 1, which is kind of a basic course you would have in the beginning, it is based on, it is using the C language. But tell you what, like a couple of years ago, it was a different language we were starting our Programming Principle 1 course. So basically, any student of Sci throughout the 4 years see at least, I think, 3 or 4 programming languages. So once you understand the basics, you would be able to switch between the languages very easy. It's like you would learn C, you would learn a standard right now C++, you would actually learn Java. In certain courses, you would see C#, R language, you would see Python. And then this is something changing. And then there is a query language, which is called SQL or SQL. You would see it in database course. So there is a very, variety of languages. But then similarly to the kind of the foreign languages we are learning, what's important, it's not important that you would learn the language. It is important you would be able to do something with this language. And then I would say programming is like writing a poem. Are you able to write a poem? Go ahead. In many cases, I need to kind of warn our students that Python, for example, is an easy language to start with. And then when many of our enthusiastic teachers, they are actually teaching Python in schools, in secondary schools, which is a good kind of stuff. But then sometimes it actually develop wrong behaviors in programming behaviors sometimes, because it's an easy language, it does many things automatically, but then you need to be aware of some stuff which actually in normal times programmers should consider. It's not a big danger, but then we need to keep it in mind too. So Python is a nice language to start with. I would recommend even without language, there are some ways of actually learning the basics. There is a Scratch program, which is basically a visual programming tool. And then you can do complex programming using Scratch. Code.org is a nice start if you have zero background. Languages, I think it's a secondary thing. Many learn Python. It's easy start. But for now, we are actually starting off with C, which is classical language. And then many modern languages have syntax which is very similar to C. My advice is like the last year taught us like the world can change drastically in a matter of very short time. I mean, the main important thing is general belief. Believe in the future, build up. If you have some passion towards the field, go for it. Don't be afraid. Don't leave your plans for the future. Okay, I will do it tomorrow or the other day. Go for it. So that's general advice. And then this is something I said also to our graduates, last year graduates. I think that's a very, very important, word, and then very important piece of advice, I think. But then generally, if you look at our specialties, they are very important today. They are going to be important for many years ahead. And then this is something I focused in our last year meeting with our students. Basically, my presentation was about algorithms, the most important notion in the world. And I was quoting one author, which is very famous nowadays, Yuval Noah Harari, who is famous author of the book Sapiens, and then there was a next book which was called Homo Deus, So brief history of tomorrow. So Sapiens was brief history of humankind, and then Homo Deus was brief history of tomorrow. So in short, this person, a historian, was putting many historical things in perspective, interesting kind of ideas, and then many people around, basically important people, I would say, around, they would find these ideas very right, very topical, very insightful. So in his book, Homo Deus, he points out that the algorithms is, if you think about one single most important notion in the world, it is the notion of algorithm. And then understanding what are the algorithms which are actually basically making all this world work. Yeah. So that is, I think, very insightful way to look at it. So computer science is very much dealing with algorithms, and the application of it is limitless. It starts with medicine, and then it's now topical. Yes, there is a global pandemic you cannot escape, and then we are very much equipped, better equipped to fight it using the technologies which are available. And then the main tool there to fight some biggest challenges of humanity right now are there. Computer science is there. So be it climate change, which is becoming really, you cannot avoid that. And then be it global kind of medical or health challenges, all of them are actually, to be solved by this young generation, including also young generation of Azerbaijanis. And then computer science gives us lots of toolkits to actually help with solving. It's not a silver bullet, obviously, but it actually gives us powerful means to meet the challenges, to solve the problems of today and tomorrow. So this is a very important field. There are lots of research going on there. There are lots of applications. And then basically the basic skill like programming is something closest to superpowers nowadays. Like, imagine you create something invisible, untouchable, you cannot touch it, intouchable or intangible, and then thousands, hundreds, thousands, millions of people would actually click something, and then it will make their life easier, change their life. So it's a very powerful skill, very powerful field. So if you have passion to the field, go for it. It's an interesting field, and then very it will bring lots of satisfaction, but you should be prepared to work hard. They should, if they believe that, if they find the passion in the field, they should believe in their powers. We are certainly here to help. And then I believe at the end of the day, they are learning themselves. I mean, any person learn themselves. We are showing the way, and then we are walking the way together. And then the world is going forward. If you don't want to stay behind, we need also to go in that direction, and we need more people in the field. Good luck with your passion. If you're passionate about, believe in your powers, go for it.